Alrighty. So, good afternoon. What I'm going to be running through today is I'm going to run through these questions, which is the knowledge retrieval for 12A in HABE. And we're going to go through proving from first principles a derivative. We're going to be using a derivative to find the gradient of a curve at a point. We're going to be also doing exactly the same, but instead we're going to be given the gradient. We need to find the actual coordinate of it. We need one here, which is just equating forces. So we have forces on all three of them together are at equilibrium. And then the last one is a probability distribution. Okay, so let's get started with the first one. So the first one here, prove from first principles. So the first thing that you need to know is that if y is equal to f of x, then our first principle says that y dash, or the derivative of it, is going to be the limit of h approaching 0 of f of x plus h minus f of x divided by h. Okay, so this, whenever you're asked about first principles, that's the key point. If you have a test question you're asked about first principles, that's what you need to do. So first off, why don't we actually, since we know y is equal to f of x, that means f of x is going to be just x cubed, just by itself. Now, that means that f of x plus h, now this is just a composite function, is going to be x plus h cubed. Now, at this stage, you should be able to use binomial distribution to make this easier. Okay, so you know it's going to be 1, 3, 3, and 1. Okay, and it's going to be x cubed, h cubed. This is going to be x squared h, and it's going to be x h squared. As you can see, all of the powers add up to 3. I'm not writing in the ones, but that's our binomial distribution. Now, I'm going to substitute that straight into the formula over here. So all I'm doing, so I've got f of x plus h, which is this. I've just simplified it. So that's going to be x cubed. Oops, I have forgotten. So you need to make sure that when you're doing this, that you're actually, every single time you're writing limit of h approaching 0, because it's a proof. Okay, so we haven't actually used this yet, because we cannot make h approach 0 because it is still a divisor. So you just can't do it. So we've got x cubed plus 3x squared h plus 3x h squared plus h cubed, and then minus f of x, which is just minus x cubed, all divided by h. Now, some of you are going to notice straight away you've got x cubed minus x cubed. Okay. The next step, if you notice, each of these here has a h in them, so you can factorize it out and then divide it. So that's what I'm going to do. So I'm going to say as my limit of h approaches 0. So I'm going to factorize the top here, which leaves me with h bracket. What's remaining? 3x squared plus 3xh plus h squared, all divided by h. Now, at this stage, if you cancel them, that just becomes 1. So you've got the limit of h approaching 0, and you've got 3x squared plus 3xh plus h squared. Now, as h approaches 0, as this happens, that's going to disappear, and that's going to become 0 as well, because when you times by 0, you get it to 0 as it approaches 0. So you need to get it off the denominator using this process, which means that y dash, the derivative of y, the derivative of x squared, is going to be equal to this expression here, which is 3x squared. Okay, that is it. So that's proof from first principles. Let's look at the next question. So, next question here. Find the gradient of the curve y is equal to 5 on x cubed at the point x equals 2. So, first off, we want to find the gradient at this point. At the point. We don't want it a chord, we want exactly that point. That tells you straight away we want a gradient, so we need a gradient function, or we need to find y dash. Now, in order to do that first, remember, this is not the nicest way to do it, because we've got x cubed on the bottom. So let's just use our indice laws to make it, bring it up to the top. So we've got y is equal to 5x to the negative 3. Using that law that 1 over x is equal to x to the negative 1. Okay, so it's just that rule. So you have to use that whenever you're doing differentiation. Now you're using the differentiation rule, dragging this number to the front and reducing it by 1. So that means y dash is going to be negative 3 times 5x to the power of negative 3 take away 1. So all I'm doing is I'm just telling you all the steps here so you can see them. So that's going to be negative 15 x to the negative 4. Now, before I do anything more, I would not substitute my value in just yet. I would always turn it back into this nice number here where it's good. So because this is a negative power, my x goes to the bottom. So that means that's the same as negative 15 divided by x to the 4th. Now I have an expression for the gradient. You have a gradient function. Now you have this. All you need to do is substitute 2 into it. So you've got y dash is going to be, so the gradient is going to be negative 15 on 2 to the power of 4, which is going to be 2 to the power of 4, which is 2, 4, 8, 16. So it's going to be negative 15 on 16. And that is your gradient at x equals 2. That's all you have to do. Now, let's look at the next one there, which is exactly the same process, but one thing that's different. So, question 3. The gradient of the curve y is equal to 2x to the 4th at the point x equals a is 27. So that tells us, it's telling us the gradient of this equation is 27 at this point. So y dash, we want to find when y dash is equal to 27. Oh, we need y dash first. So that's the first thing I'm going to do. So you got y, it's going to be 2x to the 4th. So y dash is going to be, so drag the 4 to the front, so it's going to be 4 times 2x to the 4 minus 1, which is going to be 8x to the 3. Now, it tells us the gradient is 27, so this is equal to 27. So we've got 8x cubed is equal to 27. So that means x cubed is equal to 27 on 8. Which means we're going to cube root both of them. So x is going to be, cube root of 27 has to be a positive, and it is 3. And cube root of 8 has to be positive 2. So the value of a, okay, therefore, a is equal to 3 over 2, or 1.5. There is your answer for this one. Because at that point, using all of this here, at 1.5, our gradient is 27. All right. Let's try our next one. Okay, so this is our forces. Now, this isn't too bad, to be honest. Okay, so it says a particle is in equilibrium under the action of 3 forces given by, so it's got 3 forces. We've got F1, F2, and F3. Okay, now all that means is if it's in an equilibrium, that means that my I components all equal 0 and my j components all equal 0 when I add them together. So it's exactly what I'll do. I'm going to add all 3 of these together and make them equal to 0. So I've got 8 plus 2a plus 0 equals 0. So that's very simple. Look, already we can see that we can find out a value for a. So 8 plus 2a equals 0. So minus 8 on both sides. So you've got 2a is equal to minus 8. Therefore, a equals negative 4. So you've already found the first value here. But this is how you always would lay it out. If it tells you it's in equilibrium, this is your process. Now, while we're at it, let's have a look what we get for the j component. So the j component, okay, is we have 0 plus minus 3a, so that's minus 3a, plus b equals 0. Now, we've already found out a. So if we substitute that into here, that means we get minus 3 bracket minus 4 plus b is equal to 0. So we've got positive 12 plus b equals to 0. So b is equal to negative 12. And you get your two values of a and b. Okay. Let's go through our next one. So this one isn't too bad. So what we're going to do here is we have our probability distribution of a random variable x is given in this table. So as I was saying, sorry, we need to find the value of p. Now it says probability distribution of all of them are given here, which means if we sum all these together, the probability is going to add up to 1. Okay, so we've got 3 on 8 plus 5 on 16 plus 4p plus p is equal to 1. Okay, so a little bit of here. So this is going to be 6. That's going to be 11 on 16 plus 4p, 5p, plus p equals 1. Therefore, 5p is going to be equal to, when you do 1 minus, it's going to be 5 over 16. So p has to be equal to 1 over 16. Fairly simple. Key point, remember, the sum of all possible values in probability will always sum to 1. Just take your time and you will get it right. Sometimes you'll have to form your table just using a formula. It's just substituting values in. Now, let's look at the second one. So the second one, two values of x are chosen. So first thing I'm going to do, this is p is 1 over 16. So this here is 4 over 16. And this is 1 over 16. So on my test question, I'd always write this in. So I've got those values here. So I have the probability of all of these, and they all sum to 1. If you want, you can make this 6 over 16 if you'd like, but you don't need to. So two values of x are chosen at random. The events are independent of each other. That just means that it's not going to rely on each other. Find the probability that the product of these values is 0. Now, the biggest thing you can do if you're struggling with picturing how many different ways you can do this, is actually draw out your good old two-way table. So you have 4 options each time. You have 0, 2, 4, 6. You have 0, 2, 4, and 6. All right. Lovely table, I know. That's great. So the big point is we want where it's going to be, product's going to be equal to 0. So that is literally just going to be when you have a highlighter, it's literally this here and this here. Because anything times 0 is 0, all of these other values give you different results. So you don't need to fill it in. You can, but you don't need to fill it in, but it is a nice thing you can do. Okay, the rest of it is just some mathematics. So what's the probability of getting a 0 and a 0? Well, that's just going to get this one here, which is going to be probability of 3 over 8 times itself, which is squared. That's that one there. All right. Well, if you notice, you'll have the probability of getting a 0 and a 2, a 0 and a 2 twice. So plus 2 times. So we're going to have probability of getting let's do 0, which is 3 over 8, times the probability of getting a 2, which is 5 over 16. That would be these two here done. Okay, let's look at the next one. 0 over 4, 0 over 4. So there's 2 chances again, but this time we want, so it's 2 chances of a 0 and getting a 4, which is 4 over 16 plus, and the last one, 0 and 6, 0 and 6, 2 times 3 over 8 times 1/16. Okay, and that is it. If you struggle with which is going to be, so whether it's a sum or a product or an answer, draw a little two-way table to figure out what you need to get. Pop that into your calculator and you'll get the probability 39 on 64. Okay, that's it. Okay, comes down to taking your time with stuff like this, but really it's just popping them into this, thinking about the different ways and combinations that can happen. Thank you so much. Have yourself a great day, and I'll see you soon.